Today we shall continue our derivation of equations of uniformly accelerated motion. If you had missed the previous video where we gave the introductory part of it, I would encourage you go look up that video, watch it today, and it's really going to help you. Today we have a velocity time graph. Velocity is plotted on the vertical axis. Time is on the horizontal axis. We are looking at a body that initially possesses an initial velocity u, and then it moves along the red line to this particular point where it attains a velocity v. Okay, so and the time or duration taken for that journey is from where you have 0 here till where you have t on the time axis. At the intersection of the two axes here, we assume here that time is presumably 0, and also speed or velocity is also 0. So you can recall from your definition of acceleration, it is simply change in velocity over change in time. So we can start by saying that acceleration will be change in velocity. Change is difference, okay? So that is going to be final velocity minus initial velocity. So that will be v minus u, okay? Divided by time. Final time here is t. The initial was 0. So t minus 0, that will still give us t. Okay, that's what we have. So if you make v the subject of formula, which is purely mathematics here, but let me just show us. We have v minus u equals to a t. The next thing we do, we make v the subject of formula. Let v stay here. Let's move u. Remember, it's negative. When it crosses, it becomes positive. So that will be equals to a t plus u. We can rearrange and have that v equals to u plus a t. That's a first equation of uniformly accelerated motion. V equals to u plus a t. First equation of uniformly accelerated motion. Now, having done that, I want us to look at the diagram carefully. Look at this diagram carefully. You know, the area under a VT time graph will give you the total distance covered. If you look at this VT time graph, look at this space. You find out that this space represents a trapezium. So if you remember from the formula of area of a trapezium, that is what we are going to use to get the next equation of a motion, okay? So from 0 to u, okay, and also from t to possibly where we have v, those sides are parallel. Remember from formula for area of a trapezium, we have that area A equals to half, okay, sum of the parallel sides multiplied by height. That's for trapezium. But in this case, our area will be represented by S, which is the total distance, because area under a VT time graph, like I said earlier on, gives you total distance covered. And here, our A, we can take A from O to U, okay? U minus O will still give you U. So that will be U plus B from still O to V, you know, along the vertical axis, okay? So V minus O will still give us what? V. That's all. And then here to here, okay, our height will be from here 0 to t, okay? So the difference along the time axis will be our height here. So that will still be what? T. So that is it. So we have that S equals to half U plus V, you know, multiplied by T. That's our second equation of motion, okay? So the second equation of motion, we have that S equals to half U plus V multiplied by T. Take note, we have obtained two equations of uniformly accelerated motion now on the horizontal plane. Now, the next thing we are going to do to get the next equation, we will come to equation 1 where V equals to U plus 80, and then substitute U plus 80 for the V we see in equation 2. That's all. So here, equation 2 in that case will become S equals half, okay? Remember, this is U. So in place of V, we are putting U plus 80. We are substituting the value of V in equation 1 in equation 2. So that will be plus U plus 80. Still multiplied by T, okay? So we have that. All right, so here S equals to half. U plus U, that will be 2U, okay, plus 80 multiplied by T. So let's use this T and then multiply everything there. So we will have that S equals to half, okay, 2U T plus A T squared. take note, this times this 8t squared, this times this 2ut. Okay, and then we can further use half to now multiply everything, and so we have that s equals to, let's see what happens there. Half times 2ut will give you ut. Half times 8t squared will give you half t squared. So this serves as another equation of uniformly accelerated motion, which is the third one here, that s, which is distance, equals to ut. Remember, u is initial velocity, ut plus half t squared. That's the third equation of uniformly accelerated motion. So how do we get a fourth one? For the fourth and the next equation, we will still come to equation 1. Make t time the subject of the formula. Substitute it still in equation 2. That way we'll be able to generate the fourth equation. So let's see here. From equation 1, if I make t the subject of formula, t will be equals to v minus u over a. If you don't understand how we do that, please reach out to us personally or privately. You can also watch our previous videos on change of subject of formula. It will really help you. So here we are, and then we will substitute this in equation 2. So we will now have that s equals half, okay, u plus v multiplied by v minus u over a. See that we've just done the substitution. Now s in this case, which is total distance, will be equals to u plus v. The product of u plus v and v minus u reminds you of what we call difference of two squares, an identity in mathematics. So here we will have that half, instead of the product of this, we simply say v squared minus u squared. That's what we have, v squared minus u squared, because u plus v multiplied by v minus u will give you v squared minus u squared. That's difference of two squares, okay, over this a, okay, over this a, okay. So we can simplify this further and have that s equals to v squared minus u squared over 2a. So when we cross multiply, the aim is to make v squared the subject of the formula. When we cross multiply, we'll have that v squared minus u squared equals to 2as, okay. Let's move minus u squared to the right, okay. So we have that v squared equals to u squared plus 2as. And even if you put the u squared behind 2as or in front, it does not matter, it will still give you the same. So this becomes the next equation of uniformly accelerated motion, which is going to be the fourth one. So we have that v squared is equals to u squared plus 2as. Those are the four equations of uniformly accelerated motion, and I encourage you to follow us. If you've not clicked the follow button, please do so. Continue to tag, share our videos so that those that should benefit will also benefit from this. Stay tuned.